Unit 1, Functions, Chapter 1.1, Functions, Domain, and Range. So what is a function? A relation is a function if each value in the domain there is a corresponding range. Well, what is domain? It is a set of possible x values that can make a function work. So then what is range? The range is the possible y values of a function that result when we substitute all the possible x values in the function. Now we're going to try some questions, examples A, B, and C from our workbook. These are knowledge questions. So here we have this equation. We need to write down the domain and range of each relation and then determine if it is a function. So all of the x values are the domain and all of the y values are the range. The domain is -9, -6, -5, 0, 1, 5, and 8. Now remember that domain must be placed in order from lowest to highest, and so must range. So range is -9, -8, -7, -2, 0, 5, 6, and 10. Now, is it a function? When we look back at the numbers, some of the values of the domain have more than one range element. Therefore, this is an indication that this equation is not a function. So now we have this equation. Hint, x is the domain and y is the range. So now the domain is -6, -4, -2, 0, 2, 4, 6, and 8. And remember, we always must remember how domain and range must be placed from lowest to highest. So range we have -6, -4, 2, 12, and 14, and 26. Note how 12, 2, and -4 appear more than once in the chart. When writing range, we only need to state it once. Now, is this a function? Well, each domain has a corresponding range, meaning that it is a function. Question, we have 1 over x plus 2. This is a fraction, therefore the denominator cannot equal 0 because the equation will be undefined. So now we have -2 plus 2 is equal to 0, therefore x cannot be -2 or x cannot equal -2. This is basically a restriction, and since it applies to the x value, it affects the domain. When dealing with domain and range for equations, we use certain symbols. This E-looking symbol basically represents and means belongs to, and this R-looking symbol basically means or represents real numbers. So here we have domain and range, and it basically states that x belongs to all real numbers or y belongs to all real numbers. This is the base of the domain and range when there is no restrictions. This statement reads that x and y belong to all real numbers, or that x and y can be any number, basically. That is what all real numbers mean. X or y could be any number, however, it must be a real number. Now let's go back to adding restrictions. Back to our question. We have 1 over x plus 2, and we know that x cannot equal 2. So now we need to add this x cannot equal 2 to our domain statement. So in our domain statement, we have x belongs to all real numbers, however, x cannot equal 2. Since the numerator is 1, the fraction cannot equal 0. Therefore, range is y belongs to all real numbers, but y cannot equal 0. 2. Function and function notation. What is function notation? Function notation basically means that f of x symbol represents the dependent variable y. The function f is expressed in terms of the dependent variable x. Here in this example, we have y equals 3x squared minus 2. Basically, f of x replaces the place of y and is turned into f of x equals 3x squared minus 2. Now we have ordered pairs. Ordered pairs can be expressed by using mapping notation. This is mapping notation. As we can see, we have domain and range. There are separate domains and they have one corresponding range. Therefore, they are a function. However, in this next example, we see it's not a function because although there is a single domain, it corresponds to more than one range, and that cannot happen for a function. Now with mapping notation, it can also be written, and when it's written, it replaces function notation. Here we have f of x equals 3x squared minus 2, the same question we had above. It's now written differently. As to f of x colon x transforms into 3x squared minus 2. Although it is the same equation, basically mapping notation turns it into something visually different. Now on to our chapter 2 application question. A quadratic function machine uses a function of the form f of x equals x squared plus b. The machine says that the points 1 and 3 and -2 and -3 lie on the function. Determine the values of a and b in the equation above, then write the defining equation of the final function, and also write it in mapping notation. So this is the first step to our solution. So for the point 1 and 3, we transform it into the f of x equation. So as we know, 1 is our x value and 3 is our y value. So we place 1 into the x position and 3 into the y position. Now we plug in the 1 and 3 into our equation that is given above, and then we solve. So we're left with 3 equals a plus b. So now this is going to be used as our first equation. Now we're going on to the second point. For x equals negative 2 and y equals negative 3, we're going to place it into our f of x equation. So f of negative 2 equals negative 3. Now we're going to put it into the equation we're given before, and we're left with negative 3 equals 4a plus b. This will be our second equation. So now how we're going to solve this is we're going to use elimination. Basically, we're going to subtract our equation number 2 from our equation number 1. So once we subtracted it, we're left with 3a equals negative 6. However, we cannot leave it as that. We need to isolate a. Therefore, we're going to divide 3 on both sides, and we're left with a equals negative 2. Now that we have our a value, we need to solve for b. So we're going to substitute a equals negative 2 into either our equation number 1 or equation number 2, because we need to solve for b. So I plugged it into equation number 1, and we get 5 equals b. So now we have our a and b value. So we can substitute those into the equation above and give our defining equation. Therefore, our defining equation is f of x equals negative 2 squared plus 5. We're not finished yet. Now we need to put this into mapping notation. In mapping notation, the formula is f colon x transforms into negative 2x squared plus 5.
1.3 Maximum or minimum of a quadratic function. The minimum or maximum value of a quadratic function occurs at the vertex of a parabola. The vertex of a quadratic function can be found by graphing, completing the square for fx equals a bracket x minus h bracket to the power of 2 plus k. The vertex is h comma k. Partial factoring for fx equals ax bracket x plus b over c bracket plus k. The x-coordinate of the vertex is negative b over 2a. The sign of a coefficient a in a quadratic function fx equals ax to the power of 2 plus bx plus c, or fx equals a bracket x minus h bracket squared plus k, determines whether the vertex is a minimum or a maximum. If a is greater than 0, then the parabola opens upward and has a minimum. 1.4 Working with radicals. An entire radical can be simplified to a mixed radical in the simplest form by removing the largest perfect square from under the radical to form a mixed radical. Examples: the square root of 50 equals to square root of 25 times 2, which can be also written as square root of 25 times square root of 2. So as we know, square root of 25 is 5, which we multiply to square root of 2. So now the simplified form is 5 square root of 2. Like radicals can be combined through addition and subtraction. So example of that is 3 square root of 7 plus 2 square root of 7 equals 5 square root of 7. So what we did there is we added 3 plus 2, which equals 5, and left square root of 7 as it is. Radicals can be multiplied using the distributive property. So the first example is 4 square root of 2 times 5 square root of 3 minus 3 bracket equals 20 square root of 6 minus 12 square root of 2. So all we did there is 4 square root of 2 multiplies to all the numbers in the bracket. So the next example is square root of 2 minus 3 times square root of 2 plus 1. So if we use FOIL, it will equal to square root of 4 plus square root of 2 minus 3 square root of 2 minus 3. So as we know that square root of 4 is 2, and as we know that before the square root of 2 there's a 1, so we use addition for radicals. So 1 positive 1 with negative 3 equals negative 2. So now there's a negative 2 in front of the square root of 2, and we keep the negative 3 as it is. So now we simplify it to negative 2 square root of 2 minus 1, since we we do minus 3 plus 2. Complete the square to determine the coordinates of the vertex. State if the vertex is a minimum or a maximum. So I use the equation fx equals x squared plus 4x plus 1. So we want to put the x squared plus 4x into a bracket. So now it equals bracket x squared plus 4x bracket plus 1, and we keep the plus 1 outside of the bracket. So to complete the square, we want to divide the b value by 2 and later on square it. So since our b value is 4, we want to divide 4 by 2, which equals 2. So now we square it. So 2 squared equals 4. And we want to put positive 4 and negative 4 into the bracket. So now the equation is x squared plus 4x plus 4 negative 4 bracket plus 1. And we want to take the negative 4 outside of the bracket. So now the equation equals x squared plus 4x plus 4 bracket negative 4 plus 1. So we know that negative 4 plus 1 equals negative 3. So now our equation is bracket x squared plus 4x plus 4 bracket negative 3. We want to factor x squared plus 4x plus 4. So now it equals bracket x plus 2 bracket squared negative 3. So now our equation can equal to fx equals a bracket x minus h bracket squared plus k. So we know that h and k are the vertex, and since the equation has negative h, we know that the h value is a negative, so it's going to be negative 2, and the k value is negative 3. And we know it is a minimum because the a value is greater than 0, and the a value for this equation is 1.
There are 3 ways to solve a quadratic equation. We can solve a quadratic equation by factoring, by completing the squares, or by using a quadratic formula. But first, what do you mean by solving a quadratic equation? Solving a quadratic equation means to find its roots or x-intercepts. If you take a look at this graph, it's a great example of what x-intercepts and roots look like. The part that touches the x-axis is the x-intercept or root. Now back to solving a quadratic equation. Now that we learned the x-intercepts and the roots are the parts where the parabola touches the x-axis, let's learn the 3 methods of solving a quadratic equation. Out of the 3 methods, there is only one new method that we haven't learned yet. So far, we've learned quadratic equation, which is x equals negative b plus minus square root of b squared minus 4ac divided by 2a. We've learned factoring, which is bracket x plus r close bracket open bracket x plus s close bracket, and the only method we haven't learned is completing the squares. We will be reviewing the last 2 methods, and also we will be learning the 3rd method.
Let's start by reviewing the quadratic formula. As we know, the quadratic equation is y equals ax squared plus bx plus c, where your y is your y coordinate, your 2 is your a value, your x is your x coordinate, the squared makes it a parabola, the 5 is your b value, the second x is also your x coordinate, and the 3 is the c value. So what you have to do is use these variables a, b, and c and plug them into the quadratic formula, which is negative b plus minus square root of b squared minus 4ac divided by 2a. So this looks like this. X equals negative b plus minus b squared minus 4ac divided by 2a. And since we already know the value of b is 5, and the value of a is 2, and the value of c is 3, we can plug them into our quadratic formula and get x equals negative 5 plus minus square root of 5 squared minus 4 times 2 times 3 divided by 2 times 2. So as we begin solving, we go through the steps, and we have negative 5 plus minus square root of 25 minus 4 times 6 divided by 4. And then we have negative 5 plus minus square root of 1, as we know is 1, divided by 4. And we begin solving for x, and we split this equation into 2 because we have the plus minus. So you have x equals negative 5 plus 1 divided by 4, and negative 5 minus 1 divided by 4. And this becomes negative 4 divided by 4, and negative 6 divided by 4. And your 2 x-intercepts and roots are negative 1 and negative 1.5.
Now let's review factoring. We will use the same equation we used last time, which is y equals 2x squared plus 5x plus 3. But remember, the factoring equation is x plus 3 times x plus s. Since we have an a value, we have to multiply our a and c value, which give us 6. And we need 2 numbers when added together to give us 5, and when multiplied give us 6. So those 2 numbers happen to be 2 and 3. So we split the 5 value into 2x squared plus 2x plus 3x plus 3. And now we factor these two, and we get 2x times x plus 1 plus 3 times x plus 1. And since x plus 1 is common, that is one of our factors, and 2x plus 3 is our other. So we have x plus 1 equals 0, so we bring the 1 over and we get x equals negative 1 as one of our roots. 2x plus 3 also equals 0, so we get 2x equals negative 3. So we divide both sides by 2 and we get x equals negative 1.5. So our two x-intercepts and roots are negative 1 and negative 1.5.
Now that we have reviewed the quadratic formula and factoring, we will be learning completing the squares. Completing the squares is fairly simple. The equation we will be using is x squared minus 6x minus 27. First, we put brackets around the first two terms in completing the squares. So we have x squared minus 6x within the brackets. You take the b value and divide it by 2, so you have negative 6 divided by 2, which gives you negative 3. Negative 3 times to the power of 2 gives you 9. So you sub in plus 9 and minus 9 within the brackets because plus 9 minus 9 give you 0. X squared minus 6x plus 9 minus 27 equals 0. Now you move the negative 9 outside of the bracket, and since you have no a value, you do not multiply it by anything. So you have x squared minus 6x plus 9 within the brackets, minus 9 minus 27 outside the brackets. So negative 9 minus 27 gives you negative 36. And x squared minus 6 plus 9 is a perfect square, so you get x minus 3 squared. So now you move the negative 36 over to the other side, giving you x minus 3 squared equals 36, and you square root both sides. The square root of 36 is plus minus 6, because positive 6 squared gives you 36, and negative 6 squared gives you 36. And you have x minus 3. You move the 3 onto the other side, so you have x equals plus minus 6 plus 3. So now you solve both sides with plus and the minus, so x equals 6 plus 3 and x equals negative 6 plus 3. So x plus 6 plus 3 gives you 9, so x equals 9. And negative 6 plus 3 gives you negative 3, so x equals negative 3. So your roots and your x-intercepts are 9 and negative 3. Determining a quadratic equation given its roots. This is very simple. So let's get the roots first. So your roots are 4 and 2, 0 and negative 5. So what you gotta remember is that it is written as x equals 4, x equals 2, x equals 0, and x equals negative 5. So you have to bring it back to the other side of the equation. So you have x equals negative 4 times x equals negative 2, x plus 0 times x plus 5. So this is written in factor form now, because these are your two factors, because both roots are x equals r1 and times x equals r2. So r1 is root 1 and r2 is root 2. So now you solve this. So you multiply your two brackets together and get a quadratic equation. So x times x gives you x squared, x times negative 2 gives you negative 2x, negative 4 times x gives you negative 4x, negative 4 times negative 2 gives you 8. Now you put negative 2x and negative 4x together, which gives you x squared minus 6x plus 8. So this is how you turn your two roots, 4 and 2, into a quadratic equation. Now moving to the other side. So you have 0 and negative 5. When you bring them to the other side of the equation, you got x plus 0 times x plus 5. Now that this is in factored form, we can turn it into a quadratic equation. X times x gives you x squared, x times 5 gives you 5x, 0 times x gives you 0, 0 times 5 gives you 0. So you have x squared plus 5x plus 0. Since you are adding 0, you can take it out of the equation, and you get x squared plus 5x. And this is your quadratic equation for these two roots. And this is how you turn two roots into a quadratic equation.
Explain what method you would use to solve the following question. Y equals x squared plus 7x plus 10.
The method I would use is factoring, because there is no a value, so it's simple factoring and it's not very complex. The quadratic formula would be a very long process, and so would completing the squares. Factoring is very simple. You have y equals x squared plus 7x plus 10. So you know 5 plus 2 gives you 7, and 5 times 2 gives you 10. So you have x squared plus 5x plus 2x plus 10, and you factor out x and 2. So you have x plus 2 and x plus 5 as your two factors. So x equals negative 2 and x equals negative 5. And that's how you find your roots.
Unit 1 Functions. Chapter 1.7 Solve linear quadratic systems. What is a linear quadratic system? A linear quadratic system is a linear equation, which is an equation of a line, and a quadratic equation, which is an equation of a parabola, and together they form a system of a linear and quadratic equation. By solving a linear quadratic system, you can find where the functions meet. A linear function and a quadratic function may meet in one of the following ways. The first way is intersects at 2 points, which is a secant line. The second way is intersect at 1 point, which is a tangent line. And the third way is they never intersect. Here's a diagram that shows all the situations possible for a quadratic linear system. So the first situation is intersects at 2 points. So here you see the linear line, it intersects a parabola at 2 points here and here. The second situation is intersects at 1 point, and this linear line here intersects the parabola at 1 point. And the third situation is it never intersects, so here is the third linear line which never intersects the parabola. You can use the discriminant to determine which of the above situations occur. So the discriminant equation is d equals b squared minus 4ac. So if the discriminant is positive, which is d is greater than 0, there is 2 points of intersection. If the discriminant is 0, d equals 0, there is 1 point of intersection. If the discriminant is negative, d is less than 0, there are no points of intersection at all. How to find the exact points of intersection without graphing? So the question will give you a quadratic equation and a linear equation. So for an example, the quadratic equation will be y equals negative x squared plus 5x plus 8, and the linear equation will be y equals 2x minus 10. So step 1, substitute the linear equation into the quadratic equation. So the linear quadratic systems will be 2x minus 10 equals negative x squared plus 5x plus 8. So the 2x minus 10 is from the linear equation, and the negative x squared plus 5x plus 8 is from the quadratic equation. Step 2, simplify into equals 0 format, which is also known as standard quadratic equation form. So you just group the like terms and you make the equation equal 0. So that will give you x squared, because you have to move the x over the equal sign, which will make it become a positive, and negative 3x and minus 18. Step 3 is optional, but step 3 is using the discriminant to find how many points of intersections you will have. So this will just see if your final answer is correct, but you don't have to do it, it is optional. So step 3 is you can use the discriminant to determine how many points of intersection there are. So for the example, d equals negative 3 squared minus 4, 1 times negative 18, which will give you 9 plus 72, which will give you 81. And 81 is greater than 0, therefore there are 2 points of intersections. And then step 4 is using the quadratic formula to get the 2 x's. And I'm not going to get too specific because you already learned how to use the quadratic formula in past years. So the first x will give you 6, and the second x will give you negative 3. So step 5 is substitute the 2 x's into 2 separate linear equations to find the y. So our linear equation initially was y equals 2x minus 10. So you use the x that we just got, 6, and you sub it into the linear equation to get our y, which is 2. So the point of intersection, the first point of intersection is 6, 2, because the 6 is the x, which we got earlier, and now we get y, which we put there. And then the second point of intersection, we do the exact same. So we use the linear equation, and we sub in negative 3 into the x over here, x2, you see? And then that gives you negative 16, so the point of intersection is negative 3, negative 16. This is the unit 1 test that I had to do, and I didn't really do good on this test. Here are my marks: 22.5 out of 31, 9 over 20, and 3 out of 5, and that gave me about a 60%. But in my defense, the way my teacher taught me, I didn't really understand it, and I did miss a few days of class because it was the first month, which was kind of hectic. And on the test day, it was very hot, which made it really hard to think, so I didn't really complete the test at all. But yeah, I left those like blank. But yeah, this is the assessment that I did for Unit 1. Unit 1 Reflection. Functions was the first unit we learned in the grade 11 university math course. It introduced a lot of new concepts I've never seen before, including domain, range, radical, and functions itself. The workload every day was very hard because we learned one subunit every day, and if you're behind, you would have had to learn the previous subunit from the past days to catch up, and then learn the new subunit from the current day. Falling behind was pretty common because of all the other work from the other 3 courses. For me personally, I struggled with understanding domain and range because I missed a few days of class due to the SHSM program. To make up for all the classes that I missed, I had to do extra work each day to stay up to date. Other than that obstacle, the first unit was pretty easy despite all the new words and concepts. Overall, the first unit to the functions course was easy in my opinion, but my unit test did not reflect my full knowledge and potential, which left me disappointed and unsatisfied.